ওকে, শুনতেছো আমাকে তোমরা? Can you hear me? শুনতেছো আমাকে তোমরা?
जी सर।
Okay, so maybe there is a problem due to Windows. My Windows is updated automatically, Windows 11, so that's why this is happening. Okay, so let's talk about the topics, which is basically which was mainly Newton's law of motion. So in case of Newton's law of motion, so first thing is that so three laws are mainly we'll mainly discuss three laws. So first one is so if you consider Newton's first law. So first is Newton's first law. Sorry. Okay, so in case of Newton's first law, it's all about the mainly inertia and mainly it's talk about the inertia and force also. So the thing is that if you consider that there is a force involved on an object, then there will be also change in velocity. So initially, if you consider there is an object here. Okay, so if you consider an object, and initially the velocity of that object is zero. Okay, so initial velocity is zero. Now the thing is that if the initial velocity is zero, that means the object is in stationary state. Now the object is not moving, it's either rightward or leftward. So if we consider the force is applied rightward direction, say F amount force. So due to this application of the force, F1 of force, there will be change in velocity. That means the object will move rightward with a certain velocity, which is v. So then from that mainly figure, or from that mainly scenario, we can say that if force is applied on an object, then there will be change in motion of an object. And another thing is that due to this application of the force, the acceleration is creating. That means change in velocity is related with the acceleration, because we know that change in velocity is equal to acceleration. So the quantity which mainly change the motion of an object, or basically create acceleration, is called force. Okay, and the unit of the force is Newton. Okay, unit of the force is Newton. The unit of the force is Newton. Okay, then another thing is that uh, there is opposition of the mainly force. So if we try to apply it force, instantly the object will not move. There is the opposition of the force. This is basically called the mainly inertia. So if you consider the first law, Newton's first law, the first law is if there is no external force is applied on an object, then the object will remain its motion, either in particular motion or in stationary. If the object is in stationary, then it will remain stationary, or if the object is moving with a certain velocity, then it will move with that velocity forever. Okay, so this is the mainly Newton's first law. That means if we applied force, the velocity of the object will change. Okay, and the thing is that mainly same motion থাকতে চাওয়ার যে প্রবণতাটা, this is called the mainly inertia. That means if you consider mainly sitting on a mainly bus, then it's moving rightward. So in that case, if there is a just driver যদি ব্রেকটা চাপে, then there will be mainly motion, mainly the upward side will try to move mainly forward, and but lower side is in mainly contact with the bus, so that's why the lower one will remain stationary. Okay, so this is the basically example of the Newton's first law. So that means the mainly if we applied force, that means we try to stop the object, then the object will stop. But if there is a mainly motion, then the object will try to remain the motion throughout the path. Okay, so in that case, the inertia is the basically, we can say it mathematically, inertia is the amount of mass. If mass is increased, then inertia is also increased. For example, if we apply 10 Newton force to move an object with 10 kg, then there will be velocity. If the mainly force is increase, then also the velocity increase. But if mass is increase due to same amount of force, the velocity will decrease. That means the increase of the mass mainly produce the inertia, more inertia. That means the opposition of the force. So ফোর্সটাকে যেই জিনিসটা বাধা বাধা দিচ্ছে, সেই জিনিসটাকে আমরা বলতেছি ইনার্শিয়া। আর ফোর্স হচ্ছে ওই ইনার্শিয়াটাকে ওভারকাম করে ওই অবজেক্টটাকে মুভ করে নেওয়ার জন্য, যে এটা হচ্ছে, দিস ইজ কল্ড ফোর্স। সো দিস ইজ দ্য অল অ্যাবাউট নিউটনস ফার্স্ট ল। এনিওয়ান হ্যাভ এনি কোশ্চেন রিগার্ডিং নিউটনস ফার্স্ট ল? বুঝতে পারছো তোমরা বিষয়টা?
Yes, sir.
Okay, then if we go to the Newton's second law, okay, just wait. So Newton's second law is about mainly force and acceleration. So the Newton statement of the Newton's second law is, just wait. Okay, so the statement is if we consider the force is related with the acceleration, that means if we applied force, then there will be acceleration produced. Then the change in velocity, or we can say change in momentum of an object. Momentum is the basically mainly mass with velocity. So if you consider velocity is v and m is mass is m, then the multiplication of these two, mv, is called the momentum of an object. Okay, mv is called the momentum of an object. So the Newton's second law is change in momentum with respect to time. So momentum is changing because applied force. So the change in momentum is proportional to the applied force. So the if the force is not applied, then it's okay, that there is no change in momentum, that there is no change in velocity, the change in momentum is zero. But if there is a force is applied, so in that case there will be acceleration produced, and also the momentum will change. So that means if you consider initial velocity is u and final velocity is v, then mu is the initial momentum and mv is the final momentum. Then change in momentum will be mv minus mu. Okay, mv minus mu, this is the basically change in momentum. So this change in momentum with respect to time, so if you consider the change in momentum divided by time, this is equal to, we can say this is equal to applied force F. Okay, so this is equal to applied force F. Okay, so the main concept is the rate of change of momentum. The rate of change, rate, that means with respect to time, the rate of change of momentum is directly proportional to applied force. So proportionality constant is 1. So that's why I F equal to mv minus mu by t. Then we know that if we take common m, then mv minus u by t. So we know that v minus u by t is acceleration according to the equation of motion, which is v equal to u plus at. So if v equal to u plus at, then we can say that acceleration equal to v minus u by t. Then finally, you can say that the force F, will be equal to uh, force F will be equal to ma, because m is the common here. If you take common, and then v minus u by t is a, so ma, so f equal to ma. So this is the basically mathematical, final mathematical equation of Newton's second law. So you have to use this equation to solve the problems. Okay, so f equal to ma. Now we know that the force and acceleration is a vector quantity, so you have to take this equation as a vector form. Okay, so then F vector is equal to m a vector. This is the Newton's second law. Okay, so before going to the problem solving thing, let's talk about the Newton's third law. So Newton's third law is every action has an equal and opposite reaction. Okay, so equal and opposite reaction. That means if we consider two box, say here is two box. First one is mass is say consider m1, and say second one mass is m2. Okay, so they are in stationary in a surface. Now if we applied a force along that direction, say this is f1. Now this f1 force is acting on m1 object. Okay, so this f1 force is acting on m1 object but not in m2, but there is a certain amount of force is acting on m2, which is basically the action force by m1. That means the force acting on m2 along that direction will be considered as a f12. F12. That means is a particular amount of force, is acting on m2 from m1, and also on m1 the opposite direction there is a force acting opposite direction, which is basically f21. Okay, so if you consider this is f21. Okay, so f21. So now the relation between f12 and f21 is they are equal and opposite. So then you can say f12 is equal to f21. Okay, so f12 is equal to f21, but the sign are different. So you can say sign is minus here. Okay, sign is minus here. So if you consider the magnitude, then f12 equal to f21. So these are the main thing. Now the thing is that here you are applying force f1 on m1 object. So due to the contact between m1 and m2, there is another force is acting on m1, which is basically preventing the motion, of m1 along the rightward direction. So due to m2, there is another force acting on m1, which is along the leftward direction, f21. So the number of force acting on m1 is f1 and f21. Similarly, in case of m2, f1 is not acting on m2, but there is certain amount of force is acting, which is action force, or on M2 due to M1, which is F12. Okay, so this is the main scenario in case of, yes.
স্যার আপনি এই যে কালারটা চেঞ্জ করলে আই থিঙ্ক ভালো হবে, গ্রিন কালার না দিয়ে স্যার অন্য কালার দিলে আই থিঙ্ক ভালো হবে।
ওকে ওকে, নো প্রবলেম, এটা আমি চেঞ্জ করতেছি।
জি স্যার।
Okay, so this is the main process. Any question? কারো কোনো কোশ্চেন এখন? Okay, so these are the mainly three laws: first law, second law, and third law. Then I'll solve the problems related to the Newton's second law. Just wait. Okay. Okay, so let's solve some problems related to the mainly Newton's second law. Just wait. If we try to solve the Newton's problems using the Newton's second law, you have to know the way to draw the free body diagram, force free body diagram. Okay, so I will explain this how to draw the force free body diagram, because force free body diagram is important, because you have to mainly find out the component of the forces along the x-axis and along the y-axis. So this is basically related with the F equal to ma, because F equal to ma, this is a basically vector equation. Okay, so in case of vector equation, you have to mainly know the way to solve the component. So for example, if we consider Newton's second law, it's simple one. In Newton's second law is F equal to ma, so you know that Newton's second law is F. So F vector is equal to m a. So this is vector form, basically this is vector form F equal to ma. So we know that in two-dimensional coordinate system in x y, then this equation has two mainly components. So if you consider the x component, then x component will be, say, fx, f x is equal to max. Okay, so fx is equal to max, so we can say h is m, then ax. That means this is the x component. Now if you consider the y component of this equation, so it will be fy is equal to may. So these are the mainly two equations in component form. And another thing is that if one force is involved, then you can write down this equation. But if more than one force involved, then you have to take this is F net force. So net force, that means you have to find out the resultant of the force, because say two person is mainly pulling and pushing you with same force, then since force are acting, but there is mainly the net force is zero, so that's why there is no displacement and there is no acceleration. Then we can say since acceleration is zero, that means net force is also zero. So if more than one force involved, then you have to take the net force equation. So the F along the x-axis, F net force is equal to max. It will be the correct mainly equation. F net force along the x-axis equal to max. Similarly, F net force along the y-axis is equal to may. Okay, now the thing is that here, so if the movement of the object is along the x-axis, then the acceleration will be along the x-axis. Along the y-axis, acceleration will be 0. Okay, so let's see the mainly drawing the force free body diagram. So how to draw the force free body diagram, the rule of the force free body diagram, and equal mainly question will be like that. So say a figure is given. Okay, in figure more than one force is involved, and the forces are given, and also mainly the mass of the object is given. So you have to find out, first question will be just draw the force free body diagram. Okay, drawing the force free body diagram, there will be certain marks, say 2 marks or 3 marks to drawing the force free body diagram. And the thing is that without drawing the force free body diagram, you cannot solve solve the problem related to this Newton's second law of motion. Okay, so these are the mainly the main thing. So let's see the how to draw the force and free body diagram. Okay, so first thing is that if we just consider a scenario like that, there is an object on a surface. Okay, and the mass of the surface object is m, and we are applying force along that direction. So which is F1, F1, and if you consider this line, so F1, this angle is produced 30 degree. So if you consider this is 30, it's 30, and another force is acting along that direction, which is F2, F2, and say another force is acting along that direction, which is F3, F3, and the angle produced with x-axis or F2 is say 20 degree. Now the question is F1, F2 and F3 are given in magnitude, and also the mass of the object is given. So you have to find out the acceleration of this object. So first thing is that just draw the force and free body diagram, then find out the acceleration of that object, and last question will be find the reaction force on that object due to mainly applied of this force, reaction force by the surface. So যেই সারফেসের উপর আছে ওই সারফেসের রিঅ্যাকশন ফোর্সটা বের করতে বলছে. Okay, so to solve this problem you have to just remember different type of forces. So yes, so first force is, we consider first thing, which is mainly weight or gravitational force. So weight is always remain present on an object. So if there is a mass, so if mass is 0, then there is no weight. But if there is a certain mass, then there will be certain weight. Okay, so this is the first thing, which is weight. Then second one will be mainly normal reaction force. Normal reaction force, and Then third one is say tension. Then last one is mainly friction. Friction. Okay. Here, this tension is not the tension mainly related with the usual life. So this tension is a certain amount of force. Okay, so it will related with the mainly string. Okay, so let's talk about one by one. So in case of weight, so if we try to describe the weight, so weight is always present on an object. It will act due to gravity. It's downward, and we can say that if the mass of an object is m, then the weight will be, we can say, w is equal to mg. So w is equal to, we can say, w is equal to mg. If the mass of the object is m, then m multiplied by the g will give you the mainly weight. So weight equal to mg. And normal reaction force, so normal reaction force will be different depending on the different applied force. Okay, so it's here F1, F2, F3. So also mainly these are the four forces. Out of these four forces, you have to keep in mind that the applied forces. So here in this figure, F1, F2, F3, these are the mainly applied forces. So এই চারটা ফোর্স এক এক কারণে বা এক এক বিশেষ পরিস্থিতিতে আসে, যেটা সব সময় থাকে। আর বাকিগুলো অ্যাপ্লাইড ফোর্স তো তুমি যেটা অ্যাপ্লাই করতেছো এইগুলো আর কি। সো ওয়েট সবসময়ই থাকে, W equal to mg is downward. And normal reaction force কখন হবে? If there is a surface involved. So if the object is in surface, say I am sitting on this mainly floor, or say sitting on this mainly particular surface. So due to my weight, there is a mainly reaction force upward direction. So this is the normal reaction force. But if the object is mainly moving downward, there is no contact between any surface, then there is no normal reaction force involved. So normal reaction force তখনই আসবে যখনই একটা অবজেক্ট সারফেসের উপর থাকবে বা সারফেসের উপর দিয়ে মুভ করতে চাবে। যেমন একটা ফ্লোরে একটা অবজেক্ট রেখে তুমি ধাক্কা দিচ্ছ, তখন ফ্লোরের ডাউনওয়ার্ড হচ্ছে ওয়েট কাজ করবে, আর উপরের দিকে একটা নর্মাল রিঅ্যাকশন ফোর্স কাজ করবে। বাট একটা অবজেক্টের উপর দিকে ছেড়ে দিছো, নিচের দিকে পড়তেছে, তখন কিন্তু তোমার কোনো নর্মাল রিঅ্যাকশন ফোর্স নাই, কারণ ওইখানে কোনো সারফেস কাজ করতেছে না। বাট যখনই সারফেসের উপর আসবে তখনই একটা নর্মাল রিঅ্যাকশন ফোর্স কাজ করবে। And this normal reaction force is denoted by n. Okay, denoted by n, and this n is equal to, this n is related with mainly frictional force, not friction. Basically this n is will be different. Okay, in this n there is no certain rule or the certain formula to find out the normal reaction force. Okay, so this is the normal reaction force n, and the tension is denoted by T. Denoted by T. So tension will involve when there is a string. Just string is attached with the object. Okay, so that means if we hang a object with a string, then the force from object towards the suspended point, or if we try to just mainly stress an object mainly attaching to string. Okay, so in that case the mainly force acting away from the object is called the tension. And friction, in case of friction, so if there is a frictional surface, if there is a frictional surface, the surface says that the surface is frictional. Then if the object is moving, opposition of the movement of the object, there is a force involved which is called friction. So the frictional force is denoted by F. So this F equal to, there is a relation between friction and normal reaction force, which is F equal to mu n. And here this mu is the coefficient of friction, so either kinetic or normally static. So this is basically, n is the normal reaction force and mu is the coefficient of friction. It will be given. Okay, and friction will act opposite direction of the motion. So এখন আমি একটা একটা করে দেখাই দিচ্ছি তোমাদের। সে ইফ ইউ কনসিডার, ওই প্রবলেমটাতে আমরা পরে যাচ্ছি সলভ করার ক্ষেত্রে। সো ইফ ইউ কনসিডার দ্যার ইজ আ অবজেক্ট on a surface, okay, object on a surface, then the weight will act downward. So since we are mainly dealing with the forces, so we need to know the direction of the forces because force is a vector. So weight will act downward, so W is downward, acting downward. And this there is if this object is in a surface, the object in a surface either frictional or non-frictional, not normally not frictional. So in that case the object is in surface, so that's why there is a reaction force upward direction, which is called normal reaction force, okay, or the reaction force by the floor on that object. So these are the two forces. Now here tension and friction are not involved because no forces are acting. So if we consider there is a string attached with this object, okay, also another object here. So now there is a string involved. So due to this string attached with another object, there is a force acting on that object which will move the object rightward, okay. So then the force on that string is called the tension. So this is the tension T, and same amount of tension will act on the second object which is away from the object upward direction towards the hanging point. যেহেতু সেকেন্ড অবজেক্টটা হ্যাঙ্গিং অবস্থায় আছে, হ্যাঙ্গিং পয়েন্টের দিকে সেম টেনশন টি। সো দেখো সেম টেনশন একই স্ট্রিং থাকলে সেম টেনশন হবে। সো ইন দ্যাট কেস ইফ ইউ কনসিডার দিস ইজ M1 and this is M2, so the tension, the direction of the tension for M1 is rightward and direction of tension M2 is upward. So this is the tension. Tension is involved when there is a string involved. So it's either hanging or moving rightward, leftward on a surface. Okay. So this is the basically tension. Now, since the object is moving rightward, the movement is rightward direction, and the surface is frictional. So if there is friction involved, then you can say the force, also frictional force is involved, which is backward direction. Okay, along the leftward. Okay, along the leftward, this is F. So these are the mainly forces involved, and here is no external force involved, and there is no external force involved. And the thing is that if the surface is frictionless, then this part will be zero. There is no friction involved due to frictionless surface. Okay, this part will be zero. F will be zero. And if there is surface involved, then normal reaction force will be like involved. And for M2, so let's see for M2. For M2, only T is acting upward and weight is acting downward, which is W. Okay, which is W. And so these two forces are acting on M2. But for M1, here four forces are acting: T, normal reaction force, weight, and friction. So the main thing is that, so যে চারটা ফোর্স দেখাইছি এই চারটা ফোর্সের ভিতরে ফার্স্ট ফোর্স যেটা ওয়েটটা সবসময়ই থাকে একটা অবজেক্টের উপর, ঠিক আছে। বাকি যে ফোর্স গুলো এটা ডিফারেন্ট সিনারিওর জন্য ডিফারেন্ট ভাবে ইনভলভ হয়। যেমন যদি কোনো সারফেসের উপর থাকে দেন নরমাল রিঅ্যাকশন ফোর্স আসবে, আদারওয়াইজ আসবে না। যেমন M2 জন্য কিন্তু নরমাল রিঅ্যাকশন ফোর্স নাই, এটা কোনো সারফেসের উপর নাই, শুধু হ্যাঙ্গিং অবস্থায় আছে। আবার টেনশন তখনই আসবে যখন মনে করো স্ট্রিং দিয়ে অ্যাড করা হবে, ঠিক আছে। স্ট্রিং যেমন আমি যে প্রবলেমটা দিছি তোমাদের, যে প্রবলেমটা উপরে দেওয়া আছে, এই প্রবলেমে কিন্তু টেনশন নাই, কারণ কোনো স্ট্রিং অ্যাড করা নাই, ঠিক আছে। সেক্ষেত্রে কোনো টেনশন নাই। আর ফ্রিকশনটা আসবে তখনই যখন বলা হবে সারফেসটা ফ্রিকশনাল সারফেস, আদারওয়াইজ ফ্রিকশন আসবে না। যেমন আমি যে প্রবলেমটা দিছি ওই প্রবলেমটা আসলে ফ্রিকশনলেস, সো দ্যার ইজ নো ফ্রিকশন ইনভলভ। সো এই ফোর্স গুলো ক্লিয়ার হয়েছে তোমাদের?
জি স্যার।
ওকে, সো এই ফোর্স গুলোই তোমাদের আসবে, আর বাকি অন্য কোনো ফোর্স এখানে হয়তো বা তোমাদের ইনভলভ হবে না। সো এই ফোর্স গুলো ইউজ করে তোমাদের ফ্রি বডি ডায়াগ্রাম ড্র করে দেন নিউটন সেকেন্ড লটা ইউজ করতে হবে। সো ইউ হ্যাভ টু ইউজ নিউটন সেকেন্ড ল বেসিক্যালি। সো দ্য নিউটন সেকেন্ড ল ইজ দ্য মেইন mainly thing in that case. Okay, so you have to apply Newton's second law to solve the problems. So let's see the drawing of the Newton mainly free body diagram for m object. Okay, okay, so ফার্স্ট স্টেপ ইজ ড্রয়িং দ্য ফ্রি বডি ডায়াগ্রাম। সো কি জন্য ফ্রি বডি ডায়াগ্রাম ড্র করতেছি? ফ্রি বডি ডায়াগ্রাম ড্র না করে আমাদের এক্স এক্সিস বরাবর নেট ফোর্স এবং ওয়াই এক্সিস বরাবর নেট ফোর্সটা বের করতে পারবো না। ওকে, সো দ্যাটস ওয়াই ফ্রি বডি ডায়াগ্রাম ড্র করতে হচ্ছে। সো ফার্স্ট স্টেপ যেটা আমাদের অ্যাক্সিস ড্র করতে হবে। সো উই হ্যাভ টু কনসিডার এক্স এক্সিস অ্যান্ড ওয়াই এক্সিস। ওকে, সো সে দিস ইজ এক্স এক্সিস and this is y axis. So first we have to draw the axis, then we have to keep the object in the origin. Okay, so this is the object. Then we have to find out the forces, number of forces acting on that object. So here among the four forces, weight, normal reaction force, tension and friction, so weight is always present, and since the object is in surface, then normal reaction force is also acting, but there is no tension because tension is, there is no string involved, and also there is no friction because the surface is frictionless. যদি কোশ্চেনে বলে ফ্রিকশনাল, দেন ফ্রিকশনটা আমাদের কনসিডার করতে হবে। তাহলে এই দুইটা ফোর্স আমরা দেখলাম যে এই দুইটা ফোর্স অটোমেটিক্যালি আসতেছে, ওয়েট এন্ড নর্মাল রিঅ্যাকশন ফোর্স। Without these two force and the external forces are acting, which is F1, F2 and F3. That means five forces are acting: weight, normal reaction force, F1, F2 and F3. So these five forces are acting on that M object. Now let's see, the weight is acting downward. This is W, and normal reaction force is acting upward, which is N, and the applied force F1 is acting along that direction. So আমি আগেও বলেছি তোমাদের যে ভেক্টর ড্র করতে গেলে ভেক্টরের টেলটাকে তোমার অরিজিনে রাখতে হবে, কিন্তু F1 যেটা, F1টার টেলটা কিন্তু অরিজিনে নাই। সো দ্যাটস ওয়াই আমি রিঅ্যারেঞ্জ করে F1টাকে আমি এভাবে ড্র করে দিছি। ঠিক আছে, সো ইন দ্যাট কেস ইফ দিস অ্যাঙ্গেল ইজ 30, সো দিস অ্যাঙ্গেল ইজ অলসো 30 ডিগ্রি। সো দিস অ্যাঙ্গেল ইজ 30 ডিগ্রি। সো এই যে মেইনলি যে ফ্রি বডি ডায়াগ্রামটা ড্র করার মেইন যে কনসেপ্টটা হলো, সেটা হলো আমাদের মেইনলি এই যে কম্পোনেন্টটা দেখতে হবে অবশ্যই, কারণ আমরা কম্পোনেন্ট না নিয়ে নেট ফোর্স বের করতে পারবো না। সো F1 is acting at a certain direction which is making 30-degree angle with x-axis. Then this F1 has two component. Along the x-axis it will be F1 cos 30, F1 then cos 30 degree, and along the y-axis, that means this the force is in fourth quadrant, then the force will act downward. Y component of this force will be F1 sin 30. Okay, F1 then sin 30 degree. Okay, so f1 sine 30 degree. This is the mainly y component. Now in case of f2 is acting along the x axis, so এটার কোনো কম্পোনেন্ট নাই, শুধু x এর দিকেই টোটালটা কাজ করতে। So f2, so this is f2, and f3, so here this is the f3, this is the direction of the f3. ফিবোনাচি ডায়াগ্রামটা একটু ছোট হয়ে গেছে, একটু বড় করলে হয়তো ক্লিয়ার হইতো তোমাদের এটা। So f3, this f3 produce 20 degree angle with x-axis, okay, with horizontal basically. Then this f3 has two component along the x-axis is f3x, that means f3 cos 20 degree cos 20 degree, that means f3 cos 20 degree, and along the y-axis, so it will be upward because the force is in first quadrant, so it will be f3 sine 30 degree. Okay, f3 then sine 30 degree. Okay, so this is the complete free body diagram. This is the complete free body diagram of this problem. So now we can see that here along the x-axis the components are f1 cos 30 degree, f2 and f3 cos 20 degree, and along the y-axis, positive y-axis two forces acting and negative y-axis two forces are acting. Okay, so and the thing is that the object is moving along the x-axis, there is no movement along the y-axis, so the movement along the y-axis is 0. So from that equation we can say the movement along the y-axis is 0. So then the acceleration of that object will be along the x-axis only. Okay, সো যেহেতু এটা x এর দিকে মুভ করতেছে তাহলে y এর দিকে তার কোনো অ্যাক্সিলারেশন থাকবে না, এটাই স্বাভাবিক। ওকে, সো y এর দিকে এটার অ্যাক্সিলারেশন হচ্ছে 0, বাট x এর দিকে অ্যাক্সিলারেশন থাকতেছে কারণ অবজেক্টটা x এর দিকে মুভ করতেছে, এবং x এর দিকে আমরা দেখতেছি তিনটা ফোর্স কাজ করতেছে, এবং y এর দিকে আমার কয়টা ফোর্স কাজ করতেছে, চারটা ফোর্স কাজ করতেছে, এবং সেই থেকে পজিটিভ নেগেটিভের দিকেও আছে, বাট x এর দিকে নেগেটিভের দিকে কোনো ফোর্স নাই। দ্যাট মিনস অল অফ দ্য ফোর্সেস along the positive x-axis are mainly helping the object to accelerate. Okay, so in that case the fx, if you consider the fx, that means f net x, okay, fx net force যদি আমরা কনসিডার করি, fx then fx net force,
Sir, I had a question.
yes,
The y component of F3 force, এটা কি F3 sin 20 degree হওয়ার
yes
কথা না?
yes yes f3 sin 20 degree, এটা আমার মিস্টেক হয়েছে, সরি, এটা লিখতে ভুল করছি আর কি, f3 sin 20 degree, yes, যেহেতু 20 ডিগ্রি অ্যাঙ্গেল করছে 20 হবে। So if x along the x-axis, the net force along the x-axis, it will be equal to f1 cos 30 degree, f1 cos 30 degree plus f2 plus f3 cos 20 degree So this is the net force along the x-axis. So according to the formula, this net force, this net amount of force is equal to ma. It will be max, but ax is equal to here a. So ax, if you consider the acceleration, ax equal to a, and ay, y দিকে যে acceleration, it's equal to 0 because there is no movement along the y direction, so it's equal to 0. It's equal to 0. So this is the mainly equation of motion along the x-axis in Newton, according to Newton's second law. So if F1, F2, and F3 is given and mass is given, you can easily find out the acceleration. Okay, by using this equation. Now along the y-axis, if we consider the y-axis, so if we take the y component of this equation, so then according to the Newton's second law, it will be if net y is equal to may. Okay, so we consider if y net force if y net force is equal to, this is equal to, so পজিটিভের দিকে যেগুলো ওগুলো পজিটিভ, নেগেটিভের দিকে ওগুলো নেগেটিভ, দ্যাট মিন্স n পজিটিভ প্লাস f3 sin 20 degree, f3 sin 20 degree, this is the positive. Okay, f3 sin 20 degree, then minus w minus f1 sin 30 degree. So this is the net force along the y-axis, and this is equal to m ay. Okay, m ay, and we know that ay is 0. There is no acceleration along the y-axis, so that's why m into ay, that means m into 0, so this part will be 0. This part will be 0, and from that equation, if the mass is given and f1 and f3 is given, you can easily find out the n, the value of the normal reaction force. So the normal reaction force by the surface, so surface থেকে কত ফোর্স দিচ্ছে ওই অবজেক্টের উপর সেটাও বের করতে পারবা. So question was like that. So say the figure is given, f1, f2 and f3 are acting on an object. F1 is making 30-degree angle and f2 20-degree angle, and f2 is acting horizontally rightward. Then first question is draw the force and free body diagram. So this is a 3-mark question. Second question, find out the acceleration of that object. So this is say 4 marks question. And last one, find out the normal reaction force, is 3 marks question. So this is the complete set question. 3, 4, 3, so 10. So this is the process basically. So any question now? বুঝতে পারছো তোমরা সবাই?
জি স্যার।
সো এখন যদি ফ্রিকশন থাকতো, ফ্রিকশন থাকলে এই যে এক্স এর দিকে এখানে এক্সট্রা আরেকটা ফোর্স আসতো, এখানে মাইনাস এফ, ঠিক আছে, মাইনাস এফ, কারণ ফ্রিকশনটা তখন নেগেটিভ এক্সের দিকে কাজ করতো, এবং এই এফটা তুমি বের করতা এই যে এন এর হেল্প নিয়ে, যে এনটা যেহেতু পাইছো ওইটার থেকে মিউ এন মাল্টিপ্লাই করলেই ফ্রিকশনটা আসতো। ওকে, সো তাহলে ফ্রিকশন ইনভলভ হলে আমাদের হয়তো আর একটু লেন্দি করতে হবে, আর যদি টেনশন থাকে তাহলে টিটা আলাদা একটা ফোর্স হিসেবে আসবে আর কি, এই আর কি। So এই হলো ডিটেলস, আমাদের ডিটেলস অ্যাবাউট নিউটনস ল অফ মোশন। নাও এনি কোশ্চেন ফ্রম দ্যাট পার্ট? Anyone have any question?
No, sir.
না স্যার।